Hi everyone. Is my voice audible to you? And can you able to see me? Are you able to see me? Can you please confirm? Is my voice audible to you? And is my video visible to you guys? Can you confirm? Can you hear me, guys? I'm waiting for your messages. Okay. Thanks, Puspendra. Thanks, Kanishk. So whoever has joined, welcome to today's session. I want to uh, let you know that today the theme of the quiz is NLP. So we will be having a quiz on NLP. And as I said, there will be variation of questions, some suitable for the beginners, some suitable for the advanced level people. We will have 20 questions and we will go through them. Okay. So the agenda is very, very clear. Here it will be a discussion led session. So whatever you think about a question, you have to just say that why you think that. And if you are against many people's opinion, you can also say that I'm against this option because of so and so reason. Meanwhile, whoever has joined, if you can press the like button and if you can drop a message saying hi, hello, or anything, then I will know that you are here and you are into the quiz and I will immediately start the quiz. Okay. So just keep dropping your messages and keep pressing the like button if you have not done so, so that other people will also be joining. Meanwhile, what I'm going to do is I'm going to start the quiz so that people who are here, they should not be waiting and they should get going. So this is the funda here, guys. My objective here is I want to I want to give an opportunity to everyone to join anytime they want to join. Okay. So there is no feeling that if somebody joining 5 minutes late, they are missing something. So anytime people can join, just keep giving answer through the comment, and you can give your thoughts through the comment. Why one answer is correct, why one answer is not correct. The advantage if you come and join these types of quiz is in your day-to-day job you don't get any opportunity to brush up the concepts. For example, if you are working in a time series modeling kind of setup, and if I ask you randomly what is the meaning of blue score in NLP, right, you might not be able to tell me. And all of you know that in current world all of us always have to ready for the interview. So with that in mind, people who are joined late, they can also come and play. Let me share my screen and we will start. Okay. So 20 questions will keep coming. You can answer these one after another. And if you feel something should be discussed little more, we can do that. So this is the first one on your screen, guys. Which model introduced the concept of self-attention in NLP? It should be an easy one for you. So is it GPT or Transformers or CNN or RNN? What do you think is the model that introduced the concept of self-attention? Okay, Puspendra says transformers. And also I want you to tell, when you say B, just say B hyphen transformers. Okay. What happens is, right, sometimes in YouTube, there is a lag in the comment and I may move to the next slide. So just say B hyphen transformer. Okay. Going forward also. So transformer, transformer, transformer. Everybody agrees with transformer. And all of you know that RNN, most of us know that RNN and CNN are kind of does not support attention mechanism, and that is the reason models like transformer have came into picture. So the right answer here is, as most of you have said, transformers. Reason: transformers introduce the self-attention mechanism, allowing the models to focus on different parts of the input. What are the problems with RNN kind of model? The long-term memory causing some problems. Okay. Hence transformers here. Which of the following is true about BERT? It's unidirectional, it's bidirectional, it's autoregressive, it is used for language generation. What is true about BERT here? So in BERT, so you have to think how BERT is different from other models, and what makes BERT special, or what is the property of BERT that makes it do the job it is doing, right? So Sagar says B bidirectional. Himanshu says B bidirectional. Pushpendra also says B bidirectional. I'm waiting for some more people's answer. Do you think BERT is not bidirectional and these guys are wrong? Do you think that? Kanishk also says bidirectional. So out of the given options, BERT is obviously bidirectional. It is not autoregressive. This is not applicable to this. And language generation is not something we use BERT for. So it is basically a bidirectional kind of model. So the name itself says bidirectional encoder representation from transformers. That is the reason it is a bidirectional, and it reads from both sides. Okay. So autoregressive, Om Tiwari is saying, it's not something that is used in this concept. Yeah. From the full form only, it's bidirectional. Let's see the next one. What is the main purpose of tokenization? This is a question intended for the beginners, and you have to, the point of confusion could be here between what tokenization does. For the beginners, I'm saying, not for everybody. What do you think is the right answer here? Generate what word embedding? No. And what I feel is I have made some mistake here in the options. That's my gut feeling here. But you can tell me in general, what is the main purpose of tokenization? Because the option could have been slightly more clear. Okay, so basically the job of the tokenization is to give you tokens of the sentence. For example, if say I am Aman, then tokens are I, am, and Aman. Okay, these are three tokens. So from these tokens, I can do a word embedding, I can draw whatnot. Okay, so you can get confused between option A and option D. It could have been represented in a better way. But if you are saying D, that is also fine. A is also in one way fine. But if I have to choose here, I will go for option D, though I have written here option A. I think while choosing the option, right, I did not read the option D correctly. I mean, I did not pay the much attention. So if you're saying A also in one way fine, B also in one way fine. But what we have to understand here is, what does tokenization do? So as I gave you example, breaking into single tokens, and then whatever you want to do with token, you can do with that. Okay. So don't pay much attention to if there is slight confusion, just the concept is important. Let's go to the next one. What is the challenge of named entity recognition in social media text? So if you are using a NER kind of mechanism in social media text, for example, Facebook text or Twitter text or Insta text, what is the challenges you are going to get? So what is the challenges here when you are doing on social media text? So what is the property of social media text basically? So social media text could have different types of typos, different types of smileys, different types of abbreviation, right? So here we are discussing challenges. Here we are not discussing purpose. Here we are discussing challenges. Okay. So for example, let's take a word about. Somebody will write ABT, somebody will write ABUT, somebody will write AB, the different kinds of way of writing. So when you are dealing with social media text, right? The biggest challenge you are going to face is handling non-standard abbreviation and typos, because that is not standard. Okay. It's not that everybody will use that. So NER model struggles with informal text, which often include abbreviation and spelling errors. So there is nothing standardized which everybody uses. I can call for example, take a word love, LOV, love. People will say LUV or different ways of saying that, right? So some people say LOV. So what can happen is this is non-standard, and hence you are working with that, it will create challenges. What is the main advantage of using word to vec over one hot encoding? Very basic and conceptual thing here. If you use one hot encoding versus if you use word to vec, what is the basic advantage you are going to get? Okay, Himanshu says learns contextual meaning. Anyone else? I'm getting more answers on option C. Anyone else thinks it's not option C? Do you think it's not option C? Anyone? And why option C? Whoever is saying option C, why are you saying option C? How do you think that what to vec will learn the context? Can you give me a little understanding of that? How do you think what to vec will learn the context? What to vec will learn context through what? Blank. What is that? If you know what to vec two ways of working, CBOW and skipgram, going back to basics of NLP, right? So what CBOW and skipgram does, it tries to very basic, very fundamental way of learning context. It's not as good as all the advanced models have come nowadays, but a very basic way of learning the context is covered in what to vec. Okay. So what to vec learns your contextual meaning. Why? Because it learns by seeing what the next word is through CBOW and skipgram. These two things I told you, you can read about this. So the very basic way of learning skipgram. Okay, the context. Which of the following techniques reduces word to their basic form? So again, a question intended for beginners, and you can have confusion between option A, B, and D. C is anyway not a technique for reducing word to their basic form. Which of these will do that? Okay, A is tokenization, so A also goes out of picture. Out of B and D, which one is the correct one? Both of these does more or less similar kind of thing, lemmatization and stemming, but which will bring the word to its basic form? Tokenization is not the right answer here, because tokenization, as we discussed, is basically creating tokens. What to make is something different, that is to create word embeddings. So A and C goes out of the picture, only B and D. So how stemming and lemmatization is different is stemming just cut your words. Okay, it doesn't bother about what is the root word. Lemmatization takes it to the root form of the word. For example, if there is a word called playing, played, played, okay, plays, all these words will be taken to play through lemmatization. Whereas in stemming, it will just cut ing, ed, things like that. Okay, so sometimes stemming can take the word to its root word, but not always. Lemmatization, the basic fundamental is take it to the root word. So lemmatization. What is the key difference between GPT and BERT model? BERT is used for text generation, GPT is bidirectional, BERT is unidirectional. Other way around, or option D, GPT uses LSTM, BERT uses transformers. What is the key difference between GPT and BERT models, according to you? Okay, I'm getting answers option C. People are saying BERT is bidirectional and GPT is unidirectional, which is correct. BERT is bidirectional and GPT is unidirectional. So BERT reads text in both directions for context, okay, left and right both, whereas GPT is in one direction only, left to right. Fine. What is the role of attention mechanism in NLP models like transformers? This should be an easy one for you, but just read all the options once. Replaces word embedding or focuses on relevant part of input sequence, or generate text, or reduces model complexity. Here we are talking about attention mechanism. It focuses on relevant parts of the input sequence. Yes, that's correct. And people are saying B. So relevant parts of the input sequence, that is correct. All other options are useless here, because whenever we talk of attention mechanism, it's only about understanding how much a word is relevant in context to whatever is before and after that, or whatever is in the sentence. Okay. It focuses on relevant part of the input sequence. Which of the following is not a transformer based model? BERT, GPT, Robot A, or LSTM? Which of the below? Which of the following is not a transformer based model? I will come back to that option. Himanshu is asking about option D. We will see that question one more time, okay? Because if I change the screen, people may lose the context of this question. D, LSTM. Yes, LSTM is not a transformer based model. LSTM is basically an advancement of RNN kind of model. right? So these are all, but GPT, Robot A are all transformer architecture. But on the other hand, this is LSTM is not. And this one is what Himanshu is asking, how option D is not correct. Attention mechanism does not reduce your model complexity. How it will reduce? I don't think so. Model complexity is attention mechanism's job is to understand the context in a better way, but it does not guarantee to reduce your model complexity. So when we say reducing model complexity, we talk about making models simpler, right? But here we are trying to understand the context better. The purpose is not to make models simpler here. So we will not go with option D here. Okay, so let's go to the next one. What is the purpose of softmax in NLP classification tasks? So I'm sure we would have used softmax to generate word embedding, to apply dimensionality reduction, to normalize outputs into probability distributions, or to handle missing data. This should be again an easy one. To normalize output into probability distributions. So whenever we talk of softmax, we are talking about the what is there in the output layer. And in the output layer, what we try to do is we try to see how my outputs will be coming by normalizing it. Okay, so here option C. Correct. So before we move to the next one, I have one thing to discuss because we are live now. You can give me what your thoughts is. What I'm thinking is I plan to do some kind of podcasts with some people. Okay, in Unfold Data Science channel, and because people are approaching me, some old students, right, of Unfold Data Science, they are at very good package now, 25, 30 lakhs, 40 lakhs, right? So those guys want to come and share their experiences. That is one area where they are saying me, Aman, I want to share my experience if you want to on Unfold Data Science. That is one. Another is, as you know, I'm working outside of India, so I have a lot of connections here and there who are leaders in AI. Okay, those kind of people I can bring. I can also bring some researchers or some scholars from some very prestigious institutions, for example, Cambridge, or very good universities and very prestigious institutions, because I can reach them through LinkedIn. So these are different kinds of people I plan to bring and talk to them, know their experiences, know their perspective, know the things. So you have to tell me, do you think you are interested in this type of content? Do you think that if podcasts goes, because all these will be talks, you know how the podcast format, right? These will be talks. So talks can be 45 minutes to 1 hour. So my question to you is, what is your suggestion or feedback on this? Number one. Number two, what kind of people would be your choice if I try to bring some people? Can you let me know through the comment? And people who are watching this later, you can also let me know what kind of people you will be interested in. Number one, what kind of um, what areas of talks you will be interested in, what kind of knowledge you will be interested in, things like that, so that I can tune my target guests. Okay, so this one is C actually, softmax probabilities. So first we will finish that podcast topic. Okay. Um, so what I can do is I can get some very good people. And if you ask me personally, right, and if you go to my YouTube history, so if you go my YouTube, right, you will see only podcast, podcast, podcast. Podcast is something you can listen while walking, while going to office, while doing some kitchen stuff, while doing some house chores, right? Podcast is one of my favorite thing nowadays. The reason is it's listening, right? So you don't need to see into the screen. So I thought many people will be interested in this kind of format. And there are many people out there who can share a lot of knowledge with you. So imagine somebody head of AI in Microsoft, just an example, or imagine somebody working on Netflix, data science team. They can share a lot of things with you, right? So if you listen to those guys, that will be helpful. And I think that's a very nice thing to do. Let me know what you feel after the video also. People who are watching this video later, you can just drop a comment and say, what do you feel? And I have some very good guests in my mind, okay, which I can bring from all the categories, whatever I mentioned. So let's go to next one. In NLP, which term refers to the relationship between the grammatical role of a word in a sentence and its syntactic structure? So have you heard of any term which refers to relation between grammatical role and syntactic structure? It's a very simple one. So basically, if you have not heard, syntax is that which tells you that okay, this is a grammatical. This is just a terminology thing. Okay, you will not use this in your job. Just a terminology thing. This is a syntax. Okay, syntax refers to the rules governing the structure of a sentence and its grammatical arrangement of the word. So, what is your syntax? That is the word there is syntax. Okay. Which model introduced the masked language modeling as a training objective? Have you heard of something known as masked language modeling as a training objective? Anybody has ever heard of MLM, masked language modeling? So what happens in masked language modeling is basically some part of the input text is masked and then the training happens. So if you see here, but introduce the masked language modeling where certain words in the input are masked and model predicts them. So this kind of approach is called masked language modeling, and this was used in the BERT kind of setup for learning purpose. Okay, so this is called masked language modeling. But use this. What is the primary challenges in machine learning, machine translation task? Handling ambiguity in word meaning, learning a new languages, converting spoken words into text or tokenization. So here we are talking about machine translation. So you can think of there is an English sentence that needs to be converted into French. So what is the challenge that would be coming? You can think of that, and you can take some examples between languages which for example, Hindi and English only, and you can think how the sentence structure will be different, right? Yes, so ambiguity in word meanings is very, very critical here because um, context and word ambiguity make it very, very difficult. In what context, which word is used, right? That is the most difficult part here to handle. Which of the following methods generate contextual word embedding? So contextual word embedding, which of the method generate? Is it globe, what to wake? But think about when you are given the options globe, what to wake, but one of encoding is goes out of the picture. Basically, that is not useful here. So between globe, what to wake, and bird, which is better? That way you have to think. For which option you are saying A? Is it 14? 14 number question? For which number question you are saying? You are only thinking about globe and word to wake. How about bird? What happens in bird? Contextual word embeddings is what we are talking about. Okay. I'm not denying the fact that word to wake and globe have some flavors of contextual word embedding. Word to wake and globe. Okay. But if you are given an option between these three, right? But is not a embedding generation kind of application, right? But still, if you know the how BERT works internally and how the architecture is out of option A and option B, right? BERT is the one which is advancedly doing that. Okay, that is one step ahead of those two. So if these three options are given, then BERT is the right out of these three. If BERT is not there, then A and B both are correct. As we saw in one of the previous example, right? What to pick was right because we were comparing with something else. What is the major limitation of using RNNs for long sequences in NLP? Low accuracy in text generation, exploding or vanishing gradients, overfitting in small data, or lack of attention mechanism. Here again, we are talking about what is the major challenge when you are using long sequences in RNN. There could be something which could be relevant, but what is most appropriate? What happens in long sequence RNN due to which we move to the more advanced models such as LSTM. What will think about what will happen if there is no attention mechanism, and what will happen if the exploding or vanishing gradient problem comes. If there is no attention mechanism, right, then my model will not perform good, but at least my model will learn some pattern, right? At least some convergence will happen, correct? But what happens if exploding or vanishing gradient problem happens? It will never converge. It will never learn, right? It will never finish the optimization, correct? So attention mechanism not being there is a problem. Yes, I understand. But will it stop model from learning itself? No. That's a that will make model little less smarter, which is fine. But if exploding or vanishing gradient problem comes, right, it will not allow your model to converge only. So B is what I will go for in this case. RNN struggle with long sequences due to exploding or vanishing, making it hard to retain long-term dependencies. So long-term dependencies, the meaning of memory, the meaning of um, remembering what was there before, right? All those things goes out of picture if you fall into the trap of exploding or vanishing gradient problem. Correct? If you do not have attention mechanism, what will happen? You are not able to learn the context. So your model is still doing something right, but RNN's main objective is to learn the long-term dependency. And if you fall in the trap of option B, then it's gone, right? If you are saying option D, I'm not denying that fact. That is why these sessions are right for discussion. I'm not denying the fact. Lack of attention mechanism is a problem, but this B is a bigger problem. So which devil you choose, right? Out of the two devils, which devil you choose? So B is the bigger problem. What is one key advantage of using transformer over RNN for text processing? If you use transformers over RNNs, what is one key advantage? Is it faster process with parallelization? Is it reduced model complexity? Is it improved handling of speech data, or better handling of small data sets. So here people are agreeing that this is option A, faster processing with parallelization. And there is no doubt about it, because faster processing with parallelization is something that gives transformer can process an entire sequence in parallel, unlike RNN, which process sequences sequentially, making them faster. So that is what will give you edge in this scenario. In NLP, what does the term out of vocabulary refer to? So this is again a you should know these things. Okay. So whenever somebody say OOV, right, and in some of the algorithms you might be passing a parameter OOV, right? So what is the meaning of that? Words that are too frequent, words that are missing from training, words that occur in multiple languages, and words that are stop words. Okay, I'm getting some answers here. 17B, people are saying B. Anybody else thinks it's not B, it's something else? Anybody thinks OOV is something else? Okay, everybody agrees OOV is out of vocab. So many a times what could happen is your training data may not have a particular word. And when the, let's say, prediction, let's say I have trained my model on 10 different PDF files. And in those 10 different PDF files, some word is not there. And when I'm going to predict, then some unknown word comes. So my model should be able to handle it. That is called out of vocab word. Okay. And nowadays models are very smart to do all these things. But in old days, OOV used to be a keyword we used to pass and how to treat them. So out of vocab refers to words in test data that were not present in the training data. What is the purpose of blue score in NLP? And do you know what is the full form of blue score? What is the full form of blue score? Do you know? Okay. If you don't know, blue score is one of the score that is used in many natural language models or natural language research papers, natural language analysis tasks when we measure the goodness of that. And the purpose is here very simple. The machine translation is compared from a human translation. So if I as a human am converting something or doing some NLP task, machine does, let's compare how that machine is doing. So option A is right here. The blue score software is the blue score is used to evaluate how well a machine translation aligns with human reference translation. So it's kind of a score, a standardized score that is used to compare the two sequences. 19 is a simple one. Which of the following is true about sec to sec model? And my follow-up question on this will be, what are the things for which you will use sec to sec models? Sec to sec is a basic framework through which we can do multiple tasks. But one thing is common, that it always maps one sequence to another sequence. Okay. That is common in sec to sec model. And what are the things we can do here one example could be machine translation, other example could be something else. But what we do is basically mapping one sequence to another. Which technique can be used to generate word embeddings with contextual information? And here the hint is, it is not something that is old technique, it's relatively new technique that I mean to ask here. Okay, so you can choose your option. Yes, so with the hint you are able to say Elmo generates contextual word embedding by considering the entire context in which the word appears. That is the job of the Elmo. Okay. So with this, we finished all 20 things. I know in one or two questions there were some confusion in the option. For example, let's go to where the confusion was. Let's go. Let's go. This is fine. This is fine. This one I think. This one, I don't think there was any confusion. There is one where options were slightly, it could have been better. This one. What is the main purpose of tokenization? Yes, here options could have been slightly better, but the key concept is to understand how tokenization works and what is the we use that for. Okay. So option A and option D both make sense in this case. And rest of the things are fine. I don't think there were a lot of confusions. In some of these, there could be two options which may look like slightly relatable, but whichever is more relevant, that is the one we have to choose. Okay. So next week I'll bring one another quiz, another theme. Meanwhile, what you can do is when this video gets released, just go there and drop a comment saying how did you like this video, and drop a comment if you're watching this later. Also, please drop a comment saying how did you like this video, and about the podcast thing also, please drop a comment. Okay. With that in mind, I will see you all wherever you are. Take care. Have a lovely rest of the weekend. And I'll stop sharing. Blue score full form, I also forgot actually. I remember this when I gave AWS exam. Bilingual something. Let me try to find in Google and I'll give you right away. BLEU score. Bilingual evaluation under study actually. That is the meaning of blue. And you must read about it once actually. This is an interesting concept and used in multiple purposes. Read about Elmo. Elmo is a very interesting concept. It basically tells you a LSTM way or advanced model way of word embedding. Okay, so it is not a normal basic word embedding. Advanced way using these advanced NLP techniques to do the word embedding. So it's an interesting concept. There could be a lot of discussion on this. You can read. I give you some links. Okay. Fine then. Thanks everyone, and see you all. I hope you like the quiz, and we will continue with the series. Keep joining and keep learning. Have a lovely rest of the weekend.